ESD Protection for Microphones. How microphones work. Microphones as energy conversion devices. Microphones are mainly composed of vibrating diaphragms, magnets, and coils. When sound acts on the diaphragm vibrates, thereby changing the magnetic flux of the coil, thereby generating an electric current. When sound acts on the diaphragm, it vibrates. This vibration causes a change in the magnetic flux in the coil. According to the principle of electromagnetic induction, changing magnetic flux generates electric current. This current is the sound signal output by the microphone. Common microphone types include dynamic microphones, condenser microphones, and piezoelectric microphones. Different types of microphones have different working principles when converting sound signals into current signals. ESD risks from microphone contact with human body. ESD refers to the accumulation and discharge process of electrostatic charge. When an electrostatic discharge occurs between two objects, a transient current will be generated, which may cause damage to electronic equipment. Because the human body is charged, electrostatic discharge may occur when the microphone comes into contact with the human body. This discharge process may cause damage to the microphone, affecting its performance. To protect the microphone from ESD damage, some protective measures need to be taken. These measures can include using ESD protection devices, controlling the working environment, etc. Standard type, moving coil type, capacitive type, piezoelectric type, etc. Each has its own characteristics and applicable scenarios. Amplitude and frequency range. It is determined according to the application scenario. Transfer method. Wired and wireless transmission. Choose according to your needs. Applications of discrete multilayer varistors or diode arrays. Suppress ESD pulses, protect microphones, improve system stability, and reduce noise and interference. Program performance standards. Effectively protects the microphone from ESD pulses, has little impact on sound signal quality, and has good stability and reliability. Applications of discrete multilayer varistors or diode arrays. Make sure the voltage and current capabilities of the device are appropriate for the microphone application, taking into account size and packaging requirements. The device can be connected in parallel at both ends of the microphone or in series on the signal line. The specific method needs to be determined according to the actual scenario. According to the actual application conditions, adjust the varistor resistance or diode array conduction voltage to cope with ESD pulses and other situations. ESD protection capability. This solution should be able to effectively protect against ESD pulses and avoid damage to the microphone. At the same time, it should also be able to absorb and disperse the energy of the ESD pulse, protecting other parts of the system from being affected. Sound signal quality. The solution should affect the quality of the sound signal as little as possible. During the application process, it is necessary to pay attention to whether there are problems such as noise and distortion, and to optimize and deal with these problems. Stability and reliability. The solution should have good stability and reliability. During the application process, it is necessary to pay attention to issues such as temperature stability and long-term reliability of the device, and monitor and deal with these issues. IEC 61000-4-2 is the core standard for electromagnetic compatibility, EMC, ensuring the stable operation of equipment in the electromagnetic environment. The standard mainly focuses on two aspects: air discharge and contact discharge, respectively evaluating the insulation performance of the equipment in the air and the discharge performance when in contact. The air discharge voltage is usually 15 kV and the contact discharge voltage is 8 kV, ensuring that the equipment operates trouble-free under these voltages. In the plan, the air discharge protection level is 15 kV and the contact discharge level is 8 kV, which meets the requirement that the equipment will not malfunction or be damaged. The rated voltage of the microphone line is low, so choose an appropriate protection level to meet the needs and avoid excessive costs. The selection of protection level needs to consider the application scenario. If it is too high, it may lead to increased costs and reduced sensitivity. The microphone circuit was tested for air discharge and contact discharge, simulating different environments and working conditions to verify its performance. The performance of ESD protection components, such as multilayer varistors or diode arrays, under different voltages, is tested in detail to ensure that they can operate normally within the specified range. By simulating different electrostatic environments and working scenarios, the stability, reliability, sensitivity, and noise performance of the system were tested. Standard signal maximums for microphone lines are typically 5.5 VPP and maximum frequencies below 10 kHz. At this frequency, the capacitance of the suppressor does not need to be considered. This solution complies with IEC 61000-4-2 Air 15 kV contact 8 kV. ESD protection can use discrete multi-layer varistors or diode arrays.